We're going to continue with Module 3. We just got done talking about and sharing some videos that related to network vulnerabilities, malware, social engineering, and things like that. So here we're going to look at the common IP and ICMP attacks. Again, we're going to use the Cisco videos because they're really just the best ones, better than what I can do by creating new ones. So.
Let's get in the mindset of a threat actor. And in the mindset of a threat actor, we're going to talk about IPv4 and IPv6 attacks. That's all contained here in IP attacks. Now, IP, or Internet Protocol, does not validate whether the source IP address that's seen in a packet is actually the legit, real source IP address for this message. Because of this, our threat actors can send packets using a spoofed source IP address. They can put whatever source IP they want in the message. Security analysts must understand the different fields that exist in both IPv4 and in our IPv6 headers. So let's dive deeper into IPv4 and IPv6 attacks. And first, let's hit ICMP attacks. We're going to cover this in more detail in just a little bit, but threat actors are going to use our ICMP messages, which are our echo packets for the pings themselves, to discover subnets and hosts on networks. They can also use ICMP attacks to generate denial of service floods. They can even use these things to alter the host routing tables of a targeted device. With amplification and reflection attacks, our threat attackers are going to prevent legitimate users from gaining access to info, or to even use network services by using denial of service and distributed denial of service attacks. With spoofing attacks, a threat actor can spoof the source IP on a packet. We mentioned this. We can see this with blind spoofing, or we can see this with non-blind spoofing. To put more insult to injury, an attacker can be part of a man-in-the-middle attack. They would position themselves directly between a source and destination to transparently monitor, to capture, and to even control the communication, which is all network traffic moving between a source and destination. With session hijacking, a threat actor can try to gain access to the physical network and then use a man-in-the-middle attack to not just watch a session, but to actually hijack a session and become the quote, legitimate user in the conversation. So we dive deeper then into ICMP attacks themselves. And threat actors are going to use ICMP attacks for recon and for scanning. Now this is commonly used for gathering information. They want to map out the network topology. They want to discover which hosts are actually active and reachable. They can even use these attacks to identify the host operating system known as fingerprinting. You can even see the service packet that's being used. These ICMP attacks can also determine the state of a firewall and what is able to be reached and reached through. Now, threat actors don't just use discovery with ICMP, they can also use ICMP itself for denial of service attacks and distributed denial of service attacks. And our networks should have strict ICMP ACLs deployed to filter ICMP traffic on the network edge and throughout the network topology where it should not be allowed. Now, ICMP attacks themselves have a variety of different, let's say, uses, but commonly it's going to be for host verification as well as denial of service. And that's usually the ICMP echo request and the echo reply, which is the standard echo messages you have with a ping message. With ICMP unreachable messages, we can use these to perform network recon and scanning attacks. With masked reply, we can try to map an internal IP network. With the redirects, we try to lure a targeted device into sending all of its traffic through a compromised device that then utilizes a man-in-the-middle attack. And with router discovery, we try to inject bogus route entries into the actual routing table of a targeted host. Just imagine the outgoing possibilities of a targeted host having bogus route entries inside of it. Now we'd like to talk about what's the real use and tools, and here is one of them. Low orbit ion cannon. This is an older tool that's still been useful. There's a variety of flavors of it now. We have X over IC, high orbit ion cannon, and there's even some more advanced tools like Hulk, but that goes more to the application layer and not so much here at layer 3. But with tools such as low orbit ion cannon, they even allow you to connect your client to an IRC server and remotely control your low orbit ion cannon client. Pretty much this is installing a voluntary botnet to be able to then utilize with zombies to do low orbit ion cannon. Now, we're not endorsing this tool. This is only for ethical and legal purposes for use, for things like research.
That video again does an outstanding job of talking about the IPv4 and ICMP vulnerabilities. The next video in the modules is about amplification, reflection, and spoofing attacks. Again, something really interesting here, especially with the reflection attacks. So let's go ahead and start this video and include it in our extended video.
Let's jump into amplification and reflection attacks. And with amplification and reflection attacks, this is really a combined attack procedure. Our threat actors are going to use amplification and reflection both to create a denial of service. With amplification, the threat actor is going to forward an ICMP echo request message to many hosts in number. These messages that we forward to these hosts, all these messages are going to contain a spoofed source IP address. And that source IP address is of the victim we want to hit. So when we message all of these machines, all these messages have a spoofed source IP of the actual target that we want to hit with our traffic. Now the reflection is the second half of this attack, where all those hosts we message respond back to the source. That source being the poor victim with the spoofed IP address that we put in our message that we sent. So what it looks like is this. Amplification goes out. Our message could be a multicast or a broadcast to a targeted group of machines. That message includes the spoofed source IP address. The reflection, all those targeted users that we hit, are responding back with the source IP of themselves, but now the destination IP of the spoofed address that we had originated. And that poor victim, which had nothing to do with this traffic whatsoever, is being hit using that reflection. A good example of this would be using even a tool known as Smurf6, which is built and ran using Python. And using Python, you can even see here inside of the code, microseconds with the I modifier, interface victim IP, the multicast network address. We can actually see live Python code being used in a variety of our network attacks nowadays. Lastly, we have address spoofing attacks themselves. This is where we commonly can see non-blind and blind spoofing. And blind spoofing is the easiest to talk about because this is where a threat actor can't see the traffic being sent between a host device and the target. And in blind spoofing, we have our threat actor here trying to manipulate and utilize MAC addresses for their own DOS purposes. With non-blind spoofing, this is where we actually have a threat actor trying to hijack a session. They're inspecting the reply packet from a targeted victim. They try to determine the state of the firewall and the sequence number being utilized at that moment, and they try to literally take over and become a client using unethical means. Now, when it comes down to here regarding our threat actor, is they're connected to a switch on port 2. They see the MAC address of the server that's existing on port 1. The switch right now understands that the server resides on port 1. But if the threat actor spoofs the MAC address of the server and attempts to become the server, and then they communicate to the switch will learn now that the MAC address AABBCC, which was the server MAC address, that MAC address is now inbound. It's coming in on the ingress of port 2. Thus, for the switch says, oh, I understand that AABBCC, that machine has moved and now exists off of port 2. So whenever I, the switch, must send traffic to the server, of course, I will send it out now on port 2. So we have our users, which can be legitimate. We have our threat actors, which can do unethical things, all using the same network devices and network infrastructure that our normal everyday traffic runs on.